Hi everybody, today we're going to be talking about raising a power to a power. This is going to be our next topic under exponents. So we're going to talk about what that means to raise a power to a power, how are we going to solve when we have a power to a power, and what it looks like as a final answer or as a single exponent. So let's go ahead and start us off with the next page. Okay, first thing we're going to do is this. We are going to fill out this chart together, and then we're going to explain maybe a faster method of solving these problems. Okay, so if we look first of all at this first expression that we're given over here, we have 5 to the second, all of that raised to the third power. Now when you see a power to a power, what that actually means is you're going to have a power right here and you're going to raise that to another power, hence the two words power to a power. The exponent on the outside of the parentheses, which in this case is the 3, always tells us how many times we are going to write out whatever is inside the parentheses, which in this case is the base of that exponent of 3. So what that 3 is telling us is that we're going to write out 5 to the second power, or 5 squared. We're going to multiply it times itself 3 times. So let's take a look at what that would look like in expanded form. Bam, there it is. So remember, that 3 tells us that we're going to multiply 5 squared, or 5 to the second power, times itself 3 times. But notice over here our third column says we need to write that as a single exponent. Well, you all have an amazing rule when we multiply exponents that have the same base. We practiced that in the last lesson, and now we're going to apply it here when we have a power to a power. First thing we have to do is look at our bases. All 3 bases are a 5, which is awesome because that means we can apply our rule for multiplying exponents that have the same base. And our rule states when we do multiply exponents that have the same base, we add our exponents and keep the base. So this 2, we're going to add to this 2, and we're going to add that to this 2. So all of those are going to be added together. Remember, we keep our base, so our base will remain 5. And if I add 2 plus 2 plus 2, well, let's hope it comes in. Bam, it should give us 6, because 2 plus 2 plus 2 is 6. So that would be that whole given expression written with a single exponent. Let's take a look down here at the x to the 4th raised to the second power. Remember, this 2 on the outside tells us how many times we are going to multiply our base times itself. And in this situation, x to the 4th is the base. So we are going to multiply x to the 4th by itself 2 times. So let's go ahead and see what that looks like. Bam, there it is. Now we're going to apply our rules for multiplying exponents that have the same base. Because look, both of the bases of these exponents is an x. So as soon as I know I have the same base and I'm multiplying, as long as I'm multiplying exponents that have the same base, I add my exponents and I keep the base. So these will be added together. Hopefully you know 4 plus 4 is 8. So that'll look like this with a single exponent. So x to the 4th, all of that raised to the second power, written as a single exponent, is x to the 8th. Okay, this one in the middle looks kind of confusing because I have 2 sets of parentheses. But don't let that scare you, because this lovely exponent on the outside is still going to tell us exactly how many times we're going to multiply what is the base of that exponent, which is -2 raised to the third power. Now remember that -2 inside the parentheses has to stay together, because that is the base of the 3 exponent inside here. So in order to show that that negative and the 2 stay together, the negative and the 2 have to remain inside the parentheses at all times, because the negative goes with the 2. So I'm going to go ahead and I'm going to show that I'm multiplying -2 to the third power 4 times, because remember that exponent of 4 on the outside tells us that we are going to do repeated multiplication of the base -2 to the third power 4 times. So let's go ahead and finish that up. And I'm sorry I'm very slow with this lovely new system I'm using, but there we go. We have it written out. Now we're going to look at our rules of exponents. I'm multiplying exponents that have the same base. They all have the same base of -2. And when I multiply exponents that have the same base, I add my exponents. There they are. Here's my exponents that I'm adding, and I keep the base. So once again, you need to remember 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12. So this written with a single exponent will be -2, all of that raised to the 12th power. I'm assuming you will be writing a little bit neater than me. Woohoo! Okay. Now, I can't stand the fact, let's be honest, that I had to write all of that out. That kind of freaked me out, and it was overwhelming. So instead of writing it all out, is there a faster method? Well, let's look back at this original problem right here. 5 squared, all of that raised to the 3rd power. Notice these two exponents here, the 2 and the 3, and notice my final exponent of 6. Is there anything I can do with the 2 and the 3 that relate to the number 6? Well, I'm hoping you're telling me that if I take 2 and I multiply it times 3, it's going to give me that final value of 6, which is what I have over here as my final answer. So maybe when I have a power to a power, if I multiply the exponents and keep the base, it'll give me the answer as a single exponent. Let's see if it works for the other ones, though, to double check the rule. So down here, let's take a look. I have the exponents of 4 and 2. I'm raising a power to a power. As soon as I raise a power to a power, I can multiply the exponents and keep the base. So let's multiply the exponents of 4 times 2. And 4 times 2, ooh, yeah, it's matching my 8. Bam, that rule worked on that one too. That makes me really excited. Now, okay, we've got one more. Now, I know I erased it, so let me just rewrite the answer over here as a single exponent. It was -2, all of that raised to the 12th power when I wrote it in expanded form. So, let's go back to our original exponents. I have a power to a power. As soon as I have a power to a power, that means I can multiply my exponents and keep the base. Oh, gee, that's a terrible multiplication sign. Hopefully yours looks nicer than mine. And 3 times 4, oh boy, look at that. It does equal 12. So that rule is working every single time I have a power to a power. So let's write that out down here. So instead of writing out an expanded form every time we want to raise a power to a power, when working with expressions involving exponents, we can, and remember my handwriting on this program is horrendous, so you need to be neater, multiply, and I'm going to abbreviate because I can't stand using this thing here, multiply exponents, and once again I'm abbreviating, make sure you know that EXP means exponents, so we can multiply the exponents and, oh yeah, that's a nice word, and keep, oh geez, this is horrendous. It's kind of funny. Oh, keep the, and hopefully you're faster than me, base. Oh yeah, this is why my videos are so long. There you go. So remember, when we have a power to a power, we multiply the exponents and keep the base. Let's just do one practice together. Okay, rewrite each expression using a single exponent. So this, I'm hoping that you can see, is a power to a power because I have a power on the inside of the parentheses, which in this case is 17, and I have a power on the outside of the parentheses, which is the 4. So here's our power to a power. So if I were going to go ahead and write that out in expanded form, I would have to write s to the 17th power times itself. This tells me how many times? 4 times. So this is what it would look like. Beautiful. Now, you know, in this situation, you're multiplying exponents that have the same base. You can go ahead and add 17 plus 17 plus 17 plus 17, keep your base, and write it as a single exponent. But in the previous slide, we learned a faster method. So if we take our exponents and multiply them, remember 17 times 4, beautiful, and keep the base, it'll allow us to write it as a single exponent. Well, 7 times 4 we know is 28. And we know 4 times 1 is 4 plus 2 is 6. So your answer is s to the 68th power. And tell me, wasn't it much easier to multiply those two exponents than it would have been to add 17 over and over again? Geez, I hope so. And it's so much easier than writing out s to the 17th times s to the 17th times s to the 17th times s to the 17th. So hopefully you'll remember this rule and apply it every time you see a power to a power. Let's go ahead and practice this one down here. Remember, we could take this outside exponent and write it out in expanded form, which means we write out -2, all of that raised to the 5th power. We could write it out multiplying it by itself 8 times. Whew! And if we did, it would look like this. Wow! I don't want to do all that writing. Beyond that, then I would have to add 5 plus 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 5. And that is way too much work for me. So I'm just going to go ahead and recognize that I have a power to a power. I'm going to circle those two powers, and I'm going to realize that if I have a power to a power, all I have to do is multiply those exponents and keep the base. So my base is a -2. Remember, parentheses have to stay around that base to keep the negative and the 2 together, and 5 times 8 is 40. Beautiful. So much faster to write it as a single exponent that way. Hopefully this has solidified the rule. You're going to do some activities in your stations today to help you practice this new concept, and we'll see you soon. Have a great day.